Hello friends, welcome to Aptitude videos. In this video we are going to learn permutation and combination. Let's start. Look at the first question. This question is based on linear arrangement. Five men are supposed to sit on five chairs which are arranged in linear manner. In how many ways they can do it? Let's say 1, 2, 3, 4, 5 chairs. There are 5 chairs and there are 5 people to take the chairs. For this chair, the first man can take the chair, or second man can take the chair, or third, or fourth, or fifth. Any one of them can take the chairs. So we have 5 options. Now one of them took the chair. Now the same person cannot be there on the second chair at the same time. So for the second chair we have only 4 options. For the third chair we have 3 options. For the fourth chair we have 2 options and 1 options. So it actually becomes factorial 5, which is actually 5p5. Out of 5 people, 5 people are getting arranged. Similarly, if I have 7 people taking 5 chairs only, then first out of 7 people we will be selecting 5 people, and then those 5 people will be getting arranged on the chairs, which actually becomes 7p5. See here, 1 2 3 4 5, 7 6 5 4 3. This is same as 7p5. Let's look at the second question. 6 men are supposed to sit on 6 chairs which are arranged in linear manner. In how many ways they can do it if two particular friends are always together? Now they have given a condition. I'll consider this a positive condition because they have provided something to be done. Something must be done. So this will be considered as a positive condition. Let's see. Whenever they are told two people together, whether two people together, two books together, two cars together, two any physical thing together, we'll put them in one box and count it 1. So let's say two people, P1 and P2, they are together. And apart from them, there are still 4 more people. P3, P4, P5 and P6. Now as we talked about, whenever things are together, we'll put them in one box and count it 1. So 1, 2, 3, 4, 5. Factorial 5. Now these two people are together, but nobody told the first person is P1 and second person is P2. It can also be P2 and P1. So those two people can shuffle among themselves. So answer becomes factorial 5 into factorial 2, which is 120 into 2, 240. Let's look at the next one. 6 men are supposed to sit on 6 chairs, which is arranged in the linear manner. In how many ways they can do it if two particular friends are never together? Now this question is of negative condition, when the one thing should not happen, must not happen. Now we can solve this in 2 ways. Either I can solve it manually. For example, two people are never together. So if the first person is here, second person cannot be here. Second person can go here, 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 here. For the second person we have 4 options. And other people, they are free to go anywhere, so they can shuffle among themselves. This, and this, they can shuffle among themselves. So factorial 4. Now second time, now P2 is here. In that condition, P1 has only 1, 2, 3 options. So now P1 has 3 options and others are free to go anywhere, so they can shuffle among themselves. So it becomes 3 into factorial 4 and so on. Total, if I count, 4 plus 3 plus 2 plus 1 into factorial 4, which becomes 10 into factorial 4, 240. But here we have considered P1 here and P2 here. It can also be P2 here and P1 here. So the total becomes 2 into this much, 2 into this much. So it becomes 240 into 2, that is total 480. this is counted manually. But if I try to get the same answer by shortcut, now look at this. Instead of calculating two friends not together, I can calculate easily when the two friends are together, which was factorial 5 into factorial 2, the previous question. Now here, they're asking two friends not together. Two friends not to together. Two friends not together. Instead of calculating this one, what I will do, I'll calculate total minus two friends together. This will show that the two friends are not together. So total is factorial 6 minus factorial 5 into factorial 2. This becomes 720 minus 240, that is equal to 480. The answer will be same only, but this one is slightly easy to calculate. Now this condition is called negative condition. In some questions, both the conditions might be there. Positive and negative both might be there. Let's see one question like that. Six men P, Q, R, S, T, U are supposed to sit on six chairs which are arranged in linear manner. In how many ways they can do it if P wants to sit either on chair 1 or 2, this is positive condition, and Q does not want to sit on chair 5. Now the problem here is both the conditions are there, positive, negative, both are there. Let's see. 1, 2, 3, 4, 5, 6. P wants to sit on chair 1 or chair 2. Alright. So P, Q, R, S, T, U. Now because Q does not want to sit on chair 5, if I consider not chair 5 means it can be 1, 2, 3, 4, any one of them. If Q takes 2, just in case if Q takes 2, in that condition for P will have only one condition left out. P can only take one. Although in the question it tells P can take any one of them. P was supposed to have two options, chair 1 or chair 2. P was supposed to have two options, but because one of the options is taken by Q, now P has only one option, which is wrong. So the condition you have to follow, the rule you have to follow is when both the conditions are there, positive and negative, both the conditions are there, we always have to start with positive condition first, then we'll go to negative condition. So let me try it one more time. 1, 2, 3, 4, 5, 6. There are 6 people, P, Q, R, S, T, U. Now, as we talked about, we will start with the positive condition first. Here the positive condition is P wants to sit either on chair 1 or 2. So P can sit on either 1 or 2. Two options. There are two options for P. Q does not want to sit on chair 5. Now, Q does not want to sit on chair 5. So, because it is not chair 5, not the chair 5, it can be 1, 2, 3, 4 and 6. But out of 1 and 2, one of them have been taken by P, any one of them. So let's consider 1 is taken by P. In that condition, for Q we have 1, 2, 3, 4 options. Q has 4 options. And out of 6, now 2 chairs have been taken. So for others, we have 4, 3, 2, 1 options. That's the answer. 6 awards, first, second, third, fourth, fifth, and sixth, are to be given to 6 people, A, B, C, D, E, F. In how many ways they can do it if second prize cannot be given to A or C and fourth prize can only be given to B? Now, once again, you can see two conditions are there, negative and positive, both are there. So first, as the rule says, first we have to follow the positive condition. So first we'll try to satisfy this condition, fourth prize can only be given to B. Okay, let's start with that. 1, 2, 3, 4, 5, 6. First award, second award, third award, fourth award, fifth and sixth award. Now as they are telling, the second prize cannot be given to A or C, which is negative. First we'll go to positive. Fourth prize can only be given to B. Fourth prize can only be given to B. One option. Now B is gone. So if second prize cannot be given to A or C, now second prize cannot be given to A or C. A or C cannot be given. So now we are supposed to have B, D, E, F. But out of these four, B is already having fourth award. So now second has only three options. Now two awards are already given. Two people have already taken two awards. So for other awards, we have 4, 3, 2, 1 options. That's the answer. So as you can see, we started first with the positive condition, then we followed the negative condition, and then we got the correct answer. Now, in the linear arrangement, there are two more conditions: alternate and no two boys together or no two girls together. Let's look at alternate first. In the alternate, once again, there are three conditions: equal number of boys and girls, or the difference between boys and girls are 1, or the difference between the boys and girls are more than 1. This is not possible only because when the difference between boys and girls are more than 1, it cannot be arranged in the alternate manner. See here, if I try to arrange it, girl, boy, girl, boy, girl. 3 girls already arranged, but I have one more girl. Now, where can I put it? If I try to put it here, girl, girl together, not an alternate arrangement. If I try to put here, then once again, girl, girl together, not an alternate arrangement. That means this arrangement is not possible only. So, alternate arrangement is not possible when the difference between the boys and girls are more than 1. There are two more conditions left out. Let's look at the questions for that. In how many ways can 3 girls and 3 boys stand in a row such that girls and boys are sitting alternatively? Let's see. Boy, girl, boy, girl, boy, girl. This is one arrangement I'm taking. But is this the only possibility? No. There's one more. Starting with girl. Girl, boy, girl, boy, girl, boy. Now here, I have just taken the positions. I have not told whether Salman, Shahrukh, Amir, Shahrukh, Amir, Salman, Salman, Shahrukh, Amir. The boys can shuffle among themselves. So factorial 3. Similarly, the girls can shuffle among themselves. Factorial 3. And here also factorial 3 into factorial 3. And because in between them we have or here plus. So it becomes 2 into factorial 3 into factorial 3. So the point here is whenever the number of boys and girls are equal, you can simply write 2 into factorial n into factorial n. Straight away you can write the answer. Let's look at one more question. Now when the number of girls and boys are differing by 1, 4 girls, 3 boys, alternate arrangement. Let me try. Girl, boy, girl, boy, girl, boy, and girl. Positions, I have taken the positions, but the boys can shuffle among themselves and the girls can shuffle among themselves. So the point here is whenever the difference between the boys and girls are 1, in that case you can simply write factorial n into factorial n minus 1. Next type. In how many ways can 7 girls and 4 boys stand in a row such that no 2 boys stand together? Now if I try to arrange it, let me see. No 2 boys together. So boy, 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 boy. I have 7 girls. 1, 2, 3, 4, 5. I still have 2. Those 2 maybe both are here, or 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 maybe all 3 are here. Means many arrangements are possible. So we can't keep counting like that. And that too, it is just the positions. After that, we have to shuffle the boys and girls also. So we cannot keep counting like that. We have to find a shortcut. And the shortcut goes like this. Whenever no two boys together, in that condition, start with the girl first. And whenever no two girls together, start with the boys first. Let's see. No two boys together. Let me start with the girl. 7 girls. 1, 2, 3, 4, 5, 6, and 7 girls. After putting the girls here, I have to check how many positions for the boys. Let me check. 1, 2, 3, 4, 5, 6, 7, 8. 8 positions for the boys. Keep in mind, it is always one more than this one. 7 girls, so 8 positions. 7 plus 1, 8 positions. Now the point is, out of these 8 positions, the boys can take any 4 position, and the condition no two boys together will be satisfied. I'll show you how. Boy, 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 boy. Is the condition satisfied? Yes. Or boy, condition satisfied? The girls are not together, but the boys are together. Is the condition satisfied? Yes. The girls are together, but the boys are not together. So that's all matters, right? The girls can be together. The only condition which you have to satisfy is the boys should not be together. And here you can see, out of the 8 positions, the boys can take any 4 and the condition will be satisfied. So, out of the 8 positions, the boys can take any 4 positions. But then they have just taken the positions. They can shuffle among themselves. And the girls can shuffle among themselves. That's all the answer is. Out of the 8 position available, the boys took 4 position, and the boys can shuffle among themselves and the girls can shuffle among themselves. That's the answer. Now, I wrote this much just to make you understand. But if I have to get the answer in the exam, I'll just see like this. 7 girls. So the positions for the boys will be 7 plus 1, 8. 8, C4, 4 position taken, then boys shuffling, then girls shuffling. In how many ways can 5 boys form a ring? Now, for this one, the formula will be factorial n minus 1. For the circular arrangement, the formula becomes factorial n minus 1. So, here it will be factorial 5 minus 1, that is equal to factorial 4. Now, why is it factorial n minus 1? See here. 1, 2, 3, 4, 5. There are 5 chairs and there are 5 people. When the first person comes, he can see there are 5 chairs. But the number of position for the first person is only 1 position. I'll show you how. See here. The first person took this chair. Now let me check his position. When I check the position on a round table, I only look at my left and right. I don't look at the directions here. I look at how many people in my left, how many people in my right. Let me check my position here on the table. In my left, there are 1, 2, 3, 4 empty chairs. In my right, there are 1, 2, 3, 4 empty chairs. So that's the position. Let's keep in mind. In my right, there are 4 empty chairs. In my left, there are 4. Now I'm leaving this chair. I left this chair and I came on this chair. Let me check my position. In my left, there are 1, 2, 3, 4 empty chairs. In my right, there are 1, 2, 3, 4 empty chairs. Once again, the position is left, 4 empty chair, right, 4 empty chair. Isn't it the same as the last position? That means for the first person, there are 5 chairs, but the number of position is only 1. All the 5 chairs will look the same for the first person. Let's say there's a table in a hall and there are 5 chairs around this. The first person came in the room. He sat on one of the chairs. Now he went out. If I rotate the chairs and the table, and then when the person comes once again, can he identify which chair he was on? He cannot, because for him, all the 5 chairs are looking similar only. But once the first person takes the chair, now Every chair has a different position name. See here. First to my left, second to my left, third to my left, fourth to my left, or first to my right, second to my right, third to my right, and fourth to my right. Each chair has a different position name. When the second person, now he takes the chair, let's say second to his right. Now, even if he goes out, the second person remembers that he was first to the right of that first person. Now, even if the table is rotated, the first person is still there, right? So, when the second person comes back in the room once again, he can see that the first person is there somewhere. So, he will find the chair which is first to the right of that person, and that chair will be the same chair where he was sitting earlier. Second person can identify the chair, which means first person takes the chair, all the other chairs can be identified because every chair has a different position name now. That's why the point here was, for the first person there's only one position available, but for other people there are four positions, three positions, two position, one position. That's why the formula becomes 1 into factorial 4 or 1 into factorial 5 minus 1. Although the formula was factorial n minus 1, I'm writing it like this, 1 into factorial 5 minus 1, just to denote that for the first person there is one position available, for others it is factorial n minus 1. In how many ways can 6 committee members sit around a circular table if the CEO and secretary must sit together? Now, there is a round table and 6 people are supposed to take the chairs around it. So normally it was supposed to be factorial 6 minus 1. But they're telling CEO and secretary are always supposed to be together. Now whenever two things are together, two people together, we'll put them in one box and count it 1. So let's count him 1 only. 1, 2, 3, 4, 5. Factorial 5 minus 1. CEO and secretary together. They never told the first one have to be principal and second one have to be the secretary. Means those two people can shuffle among themselves. So the answer becomes factorial 4 into factorial 2. Let's look at one more question. In how many ways can 6 committee members sit around a circular table if CEO and secretary never sit together? Once again, never sit together. Negative condition. Either we can solve it manually or we can solve it like this. Not together is equal to total minus together, and total is factorial 6 minus 1 minus factorial 5 minus 1 into factorial 2. This will be the answer for the principal, the CEO and secretary never sit together. Look at the next question. In how many ways 3 girls and 5 boys sit around a circular table in such a way that no 2 girls are together? Once again, no 2 girls together. Now, whenever you see no 2 girls together, I'm going to start with the boys first. So, let's start with the boys. Round table, 5 boys. 1, 2, 3, 4, 5 boys. And the boys can take the chairs in the factorial 5 minus 1 way because it is round table. Now, let me check the positions for the girls. 1, 2, 3, 4, 5 positions. Here in the round table it is not 5 plus 1, it is just 5 position. So, for the girls we have 5 position available. Out of that 5, the girls can take any 3. And then the girls can shuffle among themselves and boys already shuffle among themselves. Now keep in mind, whichever group comes first on the table, for them it is going to be factorial n minus 1, and the next group it will be just factorial n, because now some people are already on the chair. So for this group it is not going to be for first person one chair and for one position, for other people n minus 1. It is just going to be first person also 3 positions, second person 2 positions, third person 1 position. So 3, 2, 1 factorial 3 or factorial n. But for the first group, first person only 1 position, for others it is 4, 3, 2, 1. That's why it is factorial n minus 1. So Whichever group comes first on the table, for them it is factorial n minus 1, and for the second group it is factorial n only. So 5c3 into factorial 3 into factorial 5 minus 1. In how many ways can 6 beads of different colors be strung into a necklace? Now, for this, as it is a round table like structure, we can say factorial n minus 1 or factorial n minus 1, factorial 6 minus 1. Now, there's a trouble here. Necklace can be worn upside down also. So, the bead which was in the in this direction first, if I wear this necklace upside down now, the same bead comes into this side now. Same bead comes into this side now. So for this necklace, clockwise and anti-clockwise are going to become similar only. That's why for this type of cases where the clockwise or anti-clockwise we cannot identify, or more precisely if I can say, the things which can be used upside down also, for them it is going to be factorial n minus 1 divided by 2. This can be applied for necklace, it can be applied for garland. The things which can be worn upside down also, for them it is going to be factorial n minus 1 divided by 2. In how many ways 10% can sit around a circular table so that none of them has the same neighbor in any two arrangements? Now here, as it is a round table, we are supposed to take as factorial 10 minus 1, that is factorial 9. But here, in the factorial 9, there are two arrangements which have been counted. See here, maybe first time person 1, person 2 and person 3 are like this. And in some other arrangement, person 1, person 3 and person 2 are like this. Here, both have been counted, 1 and 2. Both have been counted to get the answer factorial 9. Means the same neighbors have been counted twice. But when they told none of them has the same neighbor in any two arrangements, means neighbor should not be repeated. In that case, because the same neighbors have been counted twice, to get the arrangements where the neighbor should not be repeated, it becomes divide by 2. So answer is factorial 9 divided by 2. Committees. Now, here, let me explain the committees by taking this example only. There are 4 men and 5 women. They're asking, create a committee of 3. Now, that's 3 can be 3 men, 0 women, or 2 men, 1 woman, or 1 man, 2 women, or 0 men and 3 women. We have all these possibilities. The question can be asked like this. Create a committee of 3 having 1 woman. They might tell you only this much information. Create a committee of 3 having 1 woman. But because they already told you create a committee of 3 having 1 woman, means other 2 have to be men only. Or if they tell you create a committee of 3 having 2 women, the meaning of that is the third one have to be man only. So that is understood. You have to consider this by yourself. Now let's come back here. 3 men, 0 women. Out of 4 men, 3 men selected, and out of 5 women, 0 women selected. Here, out of 4, 2 selected, out of 5, 1 selected. Out of 4, 1 selected, out of 5, 2 selected. Out of 4, 0 selected, out of 5, 3 selected. Now let us look at this. Number of round robin matches. Now round robin, if you follow IPL first round, every team plays with every other team. This is called round robin, where every team plays with every other team. Now in this, out of 8 teams in the IPL, out of 8 teams, any 2 teams are required to play one match. Now, I just have to think, is it C or is it P? Is it selection or arrangement? Let me check. Bangalore playing with Chennai. I told Bangalore is playing with Chennai. But somebody else is telling, no. The Chennai is playing with Bangalore. Is it different match? No, both are same matches. That means the position of the name does not matter here. So it is actually selection 8C2, which is 28. That's why in IPL the total number of matches are supposed to be 28. But because they play 2 matches against each other, so it becomes 28 into 2, total 56 matches. But in normal conditions, it is out of n teams, any 2 teams required. So number of round robin matches equal to NC2. Number of handshake is also similar only. The question will be like this. In a room there are some people and each person handshaking with everybody else, then how many handshake will be there? For that, once again, number of handshake is equal to NC2, because this is same as the round robin. And A handshaking with B is same as B handshaking with A. So position of the name does not matter. That's why it is NC2. Number of knockout matches. Let's say I have 5 teams 1, 2, 3, 4, 5. I want to check how many matches are possible in the knockout. Knockout means the winner goes to the next round and loser is out of the tournament. Then how many matches will be there? Let me check. 1, 2 playing one match, 3, 4 playing one match. Now 5 is left out. But then 5 has to play with any one of the winners. So let's say he is playing with this winner. This is another match now. Now this winner has to play with this winner. This is the final. Now how many matches are there? 1, 2, 3, 4. 5 minus 1 is equal to 4. That's why the formula becomes number of knockout matches is equal to n minus 1. Let's see one question here. In a meeting there were total 45 handshakes. If each participant shook hands with each other and participant exactly once, then what is the total number of guests? As we know, the formula for handshake is equal to NC2. That is already given as 45. And if I calculate NC2, I'm going to get n into n minus 1 divided by 2 is equal to 45. Which means n into n minus 1 is equal to 90. Now what are these numbers? This will be 10 into 9 equal to 90. So n is equal to 10. There are 10 people in the room. Now this is another type. If there are 8 railway stations along a railway line, then how many different types of tickets must be printed so that the commuters can purchase a ticket from any one station to any other station? What they're asking is, from station 1 I can buy a ticket to 2, 3, 4, 5. Means the ticket types are 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7, 1 to 8, 1 to 9, 1 to 8, 2 to 1, 2 to 3, 2 to 4. These are the types of tickets. So how many types of tickets are possible? Now if I try to calculate that what is ticket? Ticket has one information: source station, destination station. This is the most important information on the ticket. Now for the source I have 8 options. Now once a station became the source, cannot be the destination. So for the destination I have only 7 options. Same station becomes the destination also, the ticket becomes Bangalore to Bangalore, which cannot be a ticket. It is not possible. So for the destination we'll have one station less. That's why it is 7. So number of options will be 56. Types of tickets will be 56. For one ticket I need 2 stations. Out of 8 I need 2. I just have to understand, is it C or P? Now see here, ticket 1 Bangalore to Delhi and ticket 2 Delhi to Bangalore. Are they the same ticket? No, those two are different tickets. In one of them the source is Bangalore, destination is Delhi, and another one destination is Bangalore and source is Delhi. So these two are different tickets. One is up ticket, one is down ticket. So position of the name matters here. That's why here the formula will be 8P2, which is equal to 56. So for types of tickets the formula becomes NP2.